project was to figure out how the project was completed.
My name is Thomas White, and my job was to look at the cultural and social implications of our system.
My name is Daguerre-Bradford, and my job was to research the different systems and determine which one was the best.
My name is Nishant, Gnawali, and my role is to research the economics of this project.
Hi, my name is Connor Barney, and I researched the background information for Cambodia. Cambodia is a country located in Southeast Asia, where monsoon season lasts 6 months out of every year. Water is everywhere, and you would not think it would be an issue. But the issue is that most of it is not clean water. In Cambodia, they try to collect rainwater in giant cement structures and store it for the rest of the year. However, parasites grow and mosquitoes lay their eggs in these structures, making the water undrinkable and dangerous. The runoff water that is collected is contaminated because it touches the ground. This is because many of the people in Cambodia use the ground as a trash can, which leads to toxins leaking to ground and surface water. Human waste, industrial runoff, arsenic, and E. coli are also located in ground and surface waters. This causes 50% of Cambodians not to have access to safe drinking water, and leads to the death of 20% of children under 5. We believe that using inexpensive filters, villages could more easily attain clean, safe drinking water in rural Cambodia, and reduce the number of deaths in these areas. Our design is a cheap and simple biosand filter. It would be easy to make and simple to fix.
We have researched numerous different types of filters and other ways of getting clean water in Cambodia. Some included wells, different types of filters, and some different types of tablets that you can put in water that'll clean it. All in all, we found that the best one would probably be a biosand filter. A biosand filter is very easy to make. It is also very cheap and cost effective. All it is a cement casing, and inside the cement casing are layers of sand and different amounts of gravel that are different sizes, and then a diffuser plate. The rest of everything else you can find in Cambodia and for extremely cheap. Then all you have to do is pour the water into the top of the filter. It'll trickle down, and as it goes down, it'll filter out all the bad bacteria and all the bad pollutants. Then by gravity, it'll push out through the hose into a bucket or into other canisters for drinking water. This is the best type of option that we could think of. Why? It's because it's cheap. It's also very easy to install and very easy to understand. Therefore, the people in Cambodia can pay for it themselves, or pay for part of it themselves, and then also help install it so that they know how to make other filters or how to fix it. And it's not powered by energy or any other type of fuel. It is by gravity, by just pouring the water in the top, and then it comes. It's much cheaper than a well, which is why it's better than a well, and cheaper than the tablets that you can use, and also better than different types of things that require energy, because it's something that they might not have access to. All in all, it also produces enough water per day for a family to be able to drink out of, if constantly running.
So now onto the cultural and ethical implications of our project. To make sure that we complete this project ethically, we plan to locally source all the materials to reduce the cost. That way we're not taking advantage of the natives, and that this is a system that they can readily afford. Culturally, we do not foresee too many issues. We just have to make sure that there is not a lack of trust between us and the natives. We will thoroughly explain the process, how it works, and that it uses no chemicals. The process is basically the same that the earth naturally uses to filter water from rain into groundwater, and we believe that if we explain this to the natives, they will have no issues with this, and it could be a very helpful system for them.
The building process of the project will take about 10 days. In the first day, the mold for the concrete will be created. The plumbing will also be done in this day. Once the mold is created, concrete will be poured in the mold. To ensure the concrete is fully cured, it will be left intact for 6 days. During this time, locals can be informed about the design of the filtration system and how to maintain it. After the concrete is cured, sand and gravel will be gathered. Since these materials are gathered from the surrounding, it might take a day. After enough materials are available, they will be added to the system, along with the diffuser plate. This will complete the design process of the system.
Our filtration system is fairly inexpensive, so it's ideal for third world countries like Cambodia. For the concrete mold, there is going to be a one-time cost of about 121,000 Cambodian rial, which is about 30 US dollars. Now, the remaining cost is going to be dependent on the availability of sand and gravel at the site of the filtration system. If no sand and gravel are available at the site, it will be about 162,000 rial. That's equivalent to 40 US dollars. And, as expected, if sand and gravel are available, the cost will only be around 61,000 rial, which is around 15 US dollars. Now, to put things into perspective, the average Cambodian family makes 950 US dollars a year, and our filtration system will only be up to $70, if not less. And this $70 isn't just for one family, but it will be split among all the families in the town or village that the filtration system is being built in. Even though the cost of the filtration system is cheap compared to its lasting usefulness, we still want to help Cambodians in building the filtration system. If sand and gravel are available, we'll split the cost of concrete and piping with them halfway, and if not, we'll split it with them 40-60. This way, there will be no economic hardships for the Cambodians, but it will still make them responsible for the filtration system, which they will have to maintain down the road.
You choose our project as opposed to many of the other projects from volunteer organizations and associations throughout the world. Our project, we believe, is superior due to the fact that it is a small-scale system that works entirely independent of outside forces. Many other projects that are currently going on in Cambodia are digging wells or providing machinery that filters water. The problem with these things is they're not a permanent solution. The well will go dry pretty quickly and can become contaminated also, so we believe that's a very bad option. Machinery takes energy, and in some of the more remote villages, this is something they do not have. Our system, just you pour in the water, and out comes filtered clean water. It's a very small system, and we're designing it to work with. The point of our project is to provide clean water and these filters to a couple families in a village. This is only phase one. We would like to, in the future, expand this to be able to provide a filter for every family in a village, and then expand that to providing our filters to many villages. But by starting small, we're hoping to learn lessons. For example, this first round of filters we believe should provide enough clean water for one family. We might find out once we get there that the family sizes are larger than we expected, and therefore we need to scale the filters up or create larger filters to generate more clean water. We can take these lessons and appeal to investors like, hey, we've tried this out and we've got a system that works. We just need more. We want to create a better system though that will always provide clean water to these villages. It will last as long as the concrete frame for the system lasts, which, if taken care of, could last for more than 20 years. All that needs to be done is every now and then, as we instructed the villagers, they need to change out the top layer of the filter, which is just sand, to clean it out. And if they do this, then there's no reason why our system cannot last for 20, 30 years. Like, it should go on for quite a long time and be a permanent fixture in these villages.
In Cambodia, citizens are deprived of the basic necessity of life, water. The lack of water itself is not the issue. Lack of potable water is the problem. The solution proposed in this report is viable because this project has been designed around the economic status of the society. This design doesn't demand for a big infrastructure. Helping hands from few locals and readily available materials will suffice. Upon the successful completion of the project, not only will the locals have the access to potable water, but will also gain a sense of camaraderie while collaborating to resolve a crisis.